So let's look at this function right here that I made up. How about y equals 4/3 x to the power of 3, take away 5/2 x to the power of 2, take away 6x plus just some number 10. Now, the goal here is to find the locations where the tangent line is horizontal. And I saw the steps that you wrote down. You said step 1, find the derivative. Step 2, set it equal to 0. That is exactly what we do. So let's try that, and then at the end I'll explain what we've done. So the derivative, you can call it y prime. And then remember the power rule. How to find the derivative term by term. What you do is you go the exponent times the coefficient. 3 times 4/3 is going to be 4. And then you keep the letter. And then what you do is you diminish or you subtract 1 from the original power. It's going to be a 2. So let's do that for all of these. So 2 times 5/2 is 5, but it's negative. And then you take 1 from 2, so it's just x to the power of 1. And now here, the derivative of negative 6x would just be negative 6. Because there is an invisible 1, the 1 times the negative 6 is negative 6. When I subtract 1 from 1, it's 0. So it's just x to the power of 0, which is 1. And the derivative of a constant is just 0. So this is what I get for the derivative. And then what you do, based on your notes, which are correct, you set the derivative equal to 0. So here's my derivative. I set it equal to 0 and I solve for x. Now, how you solve this quadratic equation, it's up to you. You could try to use factorization like one of those ones, right, where you factor, or you could try to hit this with a quadratic formula. It doesn't matter, you'll get the same result. Some students prefer the quadratic formula, which says this here. So let's solve this equation by using the quadratic formula. Now we know that this is A, this is B, and this is C. So let's try to solve this equation by using this method. So x equals, we have negative, and then in parentheses put b, which is negative 5, plus or minus the square root of b squared. So in b put parentheses, put b in parentheses, b squared minus 4 times a times c all over 2a. And now that double negative becomes positive, plus or minus. Let's see, that's positive 25. And negative times negative is positive. 4 times 4 is 16 times 6 is 96. Positive 96 because the double negative is positive. The denominator is 8. That's 121. Square root 121. And I know that the square root of 121 is just 11. So I have 5 plus or minus 11 over 8. So this creates two different answers because I have a plus and minus. So what I'll do is I'll branch this out into two setups. I'll have 5 plus 11 and then 5 minus 11 over 8. And I can solve each of these expressions. I can evaluate them. 5 plus 11 is 16. 16 divided by 8 is 2. 5 minus 11 is negative 6 over 8. That's negative 3 over 4. We have a horizontal tangent at, well, there are two locations. One of them is at 2, comma, and then we'll see. And the other location is at negative 3/4. So before we finish, let's recap what we've done. We found the derivative of the original problem here. We set the derivative equal to 0, and we decided to solve that equation by using the quadratic formula, although you could have used factoring as well. But that's a concept that usually needs reviewing. For now, let's stick with the quadratic formula. I applied quadratic formula, and I got these two values for x. X can be 2, x can be negative 3/4. And so that's why I deposited them as x coordinates for both of them, because the goal was to find the points where the tangent line is horizontal. And we have found the x coordinates, 2 and negative 3/4. Now we have to find the y coordinates. So for that, take the x coordinates one at a time and plug them into the original problem. So if I take 2 and plug it in there, I get negative 4/3 if I plug in 2 into that. And then when I plugged in -3/4 into there, I got a pretty strange decimal that it's I just rounded it, no big deal. So they wanted the points where the tangent line was horizontal. So let me explain to you exactly what just happened. And remember these points here. Check it out. In box number 1 up here, I typed in the original problem that I created. And then what I want you to see is that the green line is called the tangent line. And we want to know when the tangent line is perfectly horizontal like this. And that happens 2 times, right there and right here. So what I can do now is I can sort of pause it and I can drag it around to where I think it works. And I think that one of the locations is right here. I think that works. And if you notice, it happens at 2, -1.33, which is precisely that, 2, and that's -1 1/3. And the other location, if I zoom back out, the other location for the tangent line being perfectly horizontal, it should be, let's go back here a little bit. It should be like right, I can type this in manually because I know where it is. And the reason that I knew where it was is because you and I found it by hand, right? At -0.75, see that? That's where the other location, where the tangent line is perfectly horizontal. And there's that crazy decimal, which I rounded. So going back over here, you just go like this. So to recap this, set the derivative equal to 0 and solve. However many x values you get when you solve, those x values represent x coordinates. You find the y coordinates by taking the x coordinates one at a time and plugging them into the original problem. And then you'll have ordered pairs, which you can turn in to the teacher.